Good morning, class. Today we're going to be going over lesson 4 of Unit 9. It's very similar to what we've gone over in the past couple days on different quadrilateral types, parallelograms and rectangles. Now we're going to be looking at rhombi and squares, which are a specific type of quadrilateral. So we are going to be looking at the guided practice, which is number 1 through 3, and problem number 5, as well as the independent practice. There is a lot of independent practice problems. I'm going to do maybe half of them because a lot of them are repetitive in skills that you need to use. And so essentially what's going to happen is you are just going to watch the videos of the guided practice, and then after that watch the independent practice videos, and then you'll have enough knowledge to be able to complete your homework. So let's begin. So problem 1 says that if BC equals 4x plus 3 and AB equals 8x minus 5, find AD. So over here we have a rhombus, and a rhombus is essentially a specific type of parallelogram. Basically, it has 4 congruent sides. So it's just like a square where all the sides of the rhombus are equal to each other or congruent. And it's essentially, like I said, a parallelogram. Remember how parallelograms have parallel sides that are opposite of each other? Well, a rhombus has the same type of situation. Okay, so let's look at this. We have BC equals 4x plus 3, and AB right here is 8x minus 5. And it wants you to find AD. So it wants you to find this side. Well, since a rhombus has all 4 equal sides, that means that we can find side AD by just setting side BC equal to AB. So we're just going to set these 2 equations equal to each other, and we are going to solve for x. And then we will find what x is equal to, and then plug it into one of these side lengths, and that will give us the side of AD. So we're going to subtract 4x to the other side of the equal sign because we're trying to get x by itself on either the left or the right side of the equal sign, and the numbers on the other side. So we have 4x minus 5 equals 3. I'm just going to write that over here. We're going to add 5 to both sides, and we get 4x equals 8. And then we could divide by 4 on both sides, so x equals 2. A lot of people will stop at this point, but this is not the solution. It wants to find the length of AD. And since AD equals the side length of BC and AB and DC, we're just going to take 2 and plug it into one of these equations. So I'm going to say 8x minus 5 equals 8, and we're going to plug in 2 in for x, and we get 16 minus 5. And that will give us 11. So AD is equal to 11. Okay, so that is the first type of problem that we're looking at, understanding rhombus or rhombi, that's plural. Basically, it's very similar to what we did for rectangles, what we did previously for parallelograms, and finding the side lengths. Basically, all the sides, like I said, are equal to each other. So if we're trying to find an unknown side length and we know 2 sides, we could set them equal to each other, solve for x, plug x back into one of those equations, and we can find the side length. All right, so now we have, for problem 2, the measurement of angle ADC equaling 70. So ADC equals 70. So this whole entire length equals 70. And I don't mean length. the whole entire angle right here. I meant these two angles right here add up to 70. And then we have ABD. We want to find that right here. I'm just going to label that X degrees. We don't know what it is. However, essentially, we know that when we look at opposite angles in a rhombus, or even every single angle for that matter, since all the sides are congruent, all the angles will be congruent. So if we have a diagonal that bisects an angle, in this case it does bisect, all we're going to do to find the measurement of angle ABD, we're going to take the angle that we know, this entire angle, and since the measurement of ADC equals 70, and we're trying to find half that angle over here for the measurement of ABD, we're just going to divide that by 2, because the diagonal bisects these two angles. So it means that if we took 70 divided by 2, each of these little portions right here are going to equal 35 degrees. So, and that is problem number 2. So now we're going to look at problem number 3 of the guided practice. So problem number 3 is a type of proof. A lot of the times throughout these sections, we were looking at proofs. I'm kind of sad that we aren't meeting in person because I had some really cool activities for us to look at. Some educational technology labs and different types of assessments that I've been working hard on for spring break for us to do. It was going to be really cool. And we would have looked at some of these proofs and broke them down even further. And you could have assessed yourself to understand if you're getting the concepts. So let me draw this rhombus up here. It has 2 diagonals, and then it's L, M, Q is where the diagonals intersect, N and P. And then it says if L, M, N, P is a rhombus, write a 2-column proof to prove that triangle LQM is congruent to triangle NQM. So as always, what we're going to do for a 2-column proof is have 2 columns. We're going to have our statements, and we're going to have our reasons. And we're going to write down what's given. So we know that LMNP is a rhombus, and that is because it is given. And then we don't know, again, how far down the steps we have to go to prove in our statements that triangle LQM is congruent to NQM. So I'm just going to write it down here as triangle LQM is congruent to triangle NQM. That's what we're trying to prove. So now let's look at this. In order to prove, I just want to draw it out, LQM is congruent to triangle NQM. So these two portions of the triangle are congruent. We have to look at the certain properties. So let's just look at these two triangles that are created through the diagonals. And so what I want to do is I first want to look at these triangles and say, well, we know that LM is equal to side MN. So side LM is congruent to MN. And the reason why is that all side lengths in a rhombus are congruent. It's one of the properties that we looked at. All the side lengths in a rhombus are congruent. So we know that LM is congruent to MN and LP is congruent to PN. But we're looking at these two portions of the triangle. I'm just going to draw a dot, just to show you what triangles we're looking at right here and right here. That's what we're trying to solve. So we found out that this side length is equal to that side length. Okay. Now, what we need to do is look at the angles of the side lengths. That's what I would actually do. So I could say that, let me see. What I want to do is draw an angle right here. And I'm going to say the measurement of angle PLM is congruent to the measurement of, since I did PLM, I'm going to go M and P. And then we could say this is because opposite angles are congruent in a rhombus. So the opposite angles are congruent in a rhombus. So that means that these two angles are congruent. Now we can actually look and say that this angle right here, angle MLN, is congruent to angle MNL. So the measurement of angle MLN is congruent to the measurement of MNL. So the measurement of MLN, so this little portion right here, is congruent to the measurement of MNL. And that's because diagonals of a rhombus, they bisect an angle, making two congruent angles. So that means that if we have a diagonal bisecting those angles we just looked at in step 3, it's going to create two congruent angles right here. And that means that this angle will be equal to this angle. So now we're looking, we have side angle, and I want to just do side angle side. I know that we can end up there because we have a side, an angle. So we want to find out that these two angles are, or these two sides are congruent. And so what I'm going to say, looking at that, I think there's two ways that we can go about this. I'm just seeing if the shortcut way would be efficient. So let me look in the book real quick to see the property. The property is from page, let's see. Let's see. They actually do not show that. So what I'm going to do is, I think I am going to just look at the diagonals and then explain that process. So what I'm going to do is say diagonal LN is congruent to diagonal MP. And then I'm going to say diagonals in a rhombus are congruent. And that's because if all the angles are congruent and all the side lengths are congruent, that means that the distance between the diagonals are also going to be congruent as well. And then lastly, before we prove this, I'm going to say that segment LQ is congruent to segment QN. And that's because this is called the addition segment, meaning that these two angle or these two side lengths add up to the entire portion. So when you take LQ and basically add it to segment QN, it equals LN. So this is the, they said last section, addition segment. So I'm just going to say addition segment. And then I'll just explain it further, is that LQ plus QN equals the diagonal length of LN. There's two equal parts. All right. And then finally, we can say that triangle LQM is congruent to triangle NQM. And that's because we have a side, an angle, and a side. So side, angle, side, congruency. Side, angle, side. It's very hard to write on this board and congruency. Okay, so that is problem 3. I will give you a couple seconds to write that down. All right, and I'm going to do problem 5 of the guided practice in a little bit. I have a meeting I have to attend in 10 minutes, so I will finish up the rest of lesson 4 in a little bit later, and I should post this video later today. All right.